Welcome viewers, in this video we'll see the electrical quantities, basic electrical quantities. First we'll see the charge. The charge is nothing but a physical property of the matter that causes it to produce a force when an electromagnetic field is applied. Right? So it is a property. Charge is nothing but a property of the matter. When electromagnetic field is applied, it experiences a force. So in any object there are n number of electrons, protons and neutrons are available under normal condition. Electrons, proton and neutrons are available under normal condition. Electron is a, that positively charged, negative charge. Proton is a positive charge and neutral is neutral. There is no positive or negative. So under normal condition there is no the movement of electrons. If any external force is applied, then the atom will move from one place to another place. So while applying the external force, what will happen? The electrons are moving from one place to another place. Due to this movement, if number of electrons are less than the number of protons, then it is known as positive charge. The number of electrons are less, protons are more. You know that proton is positively charged. So the entire object is termed as positive charge. If number of electrons are less than the number of protons, then it is known as positive charge. Suppose if number of electrons are more than the number of protons, then it is known as negative charge. So if electrons are more, automatically it is a negative charge. So charge is purely based on number of electrons and proton. Under normal condition, there is no movement of atom. While applying any external force, the atoms are moving. Under that condition, if electrons are more than proton, then it is negatively charged body. If electrons are less than the number of protons, then it is called a positively charged body. So we are dealing with charge that is purely depends upon number of electrons and protons in any object. Right? So while applying external force, what will happen? The electrons are moving from one place to another place. So this movement and number of electron and what is the energy, what is the power, everything coming based on the movement of the atom. Right? So that movement of atom is nothing but current. How many atoms are moving? How many atoms are available? That refers potential difference, energy and power. Now we'll see these terms one by one, right? So all other terms is purely based on the movement of the electron while applying external force. So next we'll see the electric current. So we already discussed, if any external force is applied, the electrons are moving. Atoms are moving from one place to another place. So the flow of free electron. So this electric current, the symbol is I. The flow of free electron in a conductor is called a electric current. Right? So the current is flowing. We are saying current is flowing. Current is flowing means the flow of free electron in a conductor. So it is defined as rate of change of charge, dq divided by dt. How much the charges are moving, dq divided by dt. Right? So the flow of free electron in a conductor is called a electric current. It is defined as rate of change of charge. The symbol is I equal to dq by dt. The unit is ampere. Right. So while applying external force, the free electrons are moving. That is nothing but a electric current. And how many electrons are moving? That we'll see the next. That is called electric potential or voltage. What is that? The ability of the charged body to do the work. How the electrons are moving, how many electrons are moving, that is a potential. That is the ability of the charged body to the work, either 10 electron or 100 electrons. We are saying I have the potential to do this work. I am able to take 5 books, I am able to take 10 books. That is our potential. Similarly, here potential refers the charged body to do the work. That is nothing but work done by charge. Work done by charge is nothing but a voltage. What is the charge available? How many electrons are moving? That is nothing but work done by charge will give the voltage. The unit is volt. Next we will see the potential difference. What is the potential difference? In one place the electrons are more, another place electrons are less. So the difference in potential of two different bodies is nothing but a potential difference. In one place 100 electrons will be there, another place 1000 electrons will be there. So there is a difference in potential, that is called a potential difference. Then we'll go to the power. What is the power? The rate at which the work is done in an electric circuit is called a electric power. What is the rate? So while applying any external force, the atoms are moving. So how many atoms are moving is nothing but a electric power, right? The rate at which the work is done. So I am able to take 5 books within a 1 second. I am able to take 10 books in a 1 second. So that is nothing but power. So here the rate at which how many electrons are moving is a potential. How many electrons moving in a given time, within a time, the rate, that is nothing but a power, right? So there now so many electrons are moving, 10 by 10 electrons are moving one by one. That's called a potential. That's a power, the rate at which the work is done. So the general formula is voltage into current. The unit is watts, right? So next we will see the energy. What is energy? So it is nothing but capacity of the charged body to do the work at a given time. So I am able to take 10 book or 20 book at what time? Either 1 seconds or 1 minute or 1 hour. That refers the energy. Energy always refers voltage into current, that is power into time. What is the power consumed in a given time? That refers the energy, right? So the electrons are moving. The ability to move the electron is nothing but potential. I am able to move this book. The rate at which how many books are moving, that is the power. How many books are you are moving for a given time is the energy, right? So the electrons are moving is a potential. The electrons are moving at a given rate, that is the power. The electrons are moving given rate for a given time is the energy, right? So the unit is joule. Next we'll see the charges. What is the general term for the charge? So 1 coulomb of charge equal to 1 divided by 1.602 into 10 to the power minus 19. This universally it is a constant. The 1 coulomb of charge is this value. So 1 divided by, so it is nothing but 6.24 into 10 to the power 18 electron. 6.24 into 10 to the power 18 electron. That is 1 coulomb of charge. Suppose a single electron have a charge, positive charge or negative 2 charges available. So minus 1.60 into 10 to the power minus 19 coulomb. Similarly, single proton, that is positive, plus 1.602 into 10 to the power minus 19 coulomb, right? So this is the 1 coulomb of charge, this value. This is one single electron having the charge and one single proton having the charge, right? This is negative and this one will be positive. We will see some more quantities with the symbol and unit. Now we will see this, the quantity, symbol, unit and formula for the further electrical quantities. First we will see the charge. The charge is symbol is Q. The unit is coulomb. It is written as C. That is nothing but current into time. The formula is current into time, right? The charge, it is termed as Q. The coulomb, the unit is coulomb. It is also written as C. The formula is I into T. Then next one is the current. The symbol is I. The unit is ampere. It is written as A. That is the formula is Q divided by T. Charge divided by time. Third one, voltage. The symbol is V. The unit is volt. It is can be written as V. What is voltage? W by Q. Work done by charge. W by Q. Then energy. The symbol is W. The unit is joule. We can write it as J. Power into time. The energy always refers what is the power at a given time. P into T. Then what is the power? Power equal P. The unit is watts W. W by T. The power is nothing but W by T. The next one, resistance R. The unit is ohm. The symbol is ohm. V by I. The formula is V by I. The capacitance. The symbol is C. Farad F. Q by V. The formula is Q by V. Next, inductance L. The unit is Henry. Q by I. Then frequency. The symbol is F. Unit is hertz. 1 by T. Then impedance Z. The symbol is Z. Ohm. V by I. Then admittance. Symbol is X. Ohm. V by I. So these are all the some electrical quantities we referred with the symbol, unit and formula. So in this video we discuss about the electrical quantities, definition of electrical quantities, then unit, formula, and some more electrical quantities also discussed with the symbol and formula. Thank you. Welcome viewers. In this video we will see the SI units. What is meant by SI unit? What are the units are available? We'll see in this video. The SI is nothing but it is the abbreviation of the French word Système International. The international level the standards are defined so that everyone need to use the same standard for the uniformity. Entire universe, in order to get the uniformity we have SI units. That is the abbreviation of Système International, that is from the French word. That is nothing but international system of units. SI is nothing but international system of units. Is the metric system that is used universally as a standard for measurements. In order to get the uniformity over the entire universe, these SI units are defined. So everyone need to use these SI units for representing the measurement. The SI unit plays vital role in scientific and technological research and development. In order to we have the uniformity so that while going with any research and development it will be very useful in order to go with the uniform standards, uniform units. So there are 7 base units are available and 22 derived units are available. The 7 base unit means it is a basic. There are 7 basic units are available. From the base unit, there are 22 derived units are available. And some more derived units also available from the base. By standard, we have 22 derived units. See, these derived units are obtained from the base unit. So, only these 7 are base units. All other units are derived from this base unit. So that it is called a base unit and derived unit. This SI unit can be expressed as either as a standard multiple or fractional quantities. Standard multiple or fractional quantities. These quantities are defined with the help of prefix multipliers with the power of 10, that is ranging from 10 to the power minus 24 to 10 to the power plus 24. Right? So these SI units are represented as standard multiple or fractional quantities. That is, what is that standard multiple and fractional quantities? That is power of 10 on both the side, negative as well as positive. 10 to the power minus 24 to 10 to the power plus 24. Right? Now we'll see what are the 7 basic units, what are the 22 derived units, and what is the range from minus 24 to plus 24. How the units are represented, that also we'll see in this unit, in this video. So base unit means a fundamental unit or considered as building block of the system. So this is a fundamental units. All other units are derived from this base unit. It is a building block. From that only other units are derived. So the derived unit means the derived unit is a unit of measurement in international system of units that is derived from one or more of the 7 base units. So only this 7 base unit is the building block for all other derived units. All other derived units are obtained from these 7 base units. Now we'll see base unit, derived unit and multiples one by one. First we'll see the SI base units. So there are 7 SI base units are available. We'll see one by one. The first one will be length. The unit is meter. The symbol is M. First one is the length. The unit is meter. The symbol is M. How it is defined? How internationally defined the length? It is defined by making fixed value of the speed of light in vacuum. Right? We know what is meant by 1 meter, 2 meter mean we know, but how it is defined 1 meter, what is internationally defined, what is 1 meter? We know what is 1 meter by seeing the scale or the tab, you are easily identify meter, but how it is defined internationally is nothing but taking fixed value of the speed of light in vacuum. That is a reference. 1 meter means it's a speed of light in vacuum. Right? So the first one is length, unit is meter and symbol is M, that is defined by fixed value of speed of light in vacuum. The second one, mass, kilogram, the unit is kilogram and symbol is kg. So while purchasing any product, any material, we are referring with kilogram or gram. So that is the second one, mass. How it is defined internationally? Defined by taking fixed value of Planck constant. From the constant only we define what is 1 kg. While going to shop, we can know the 1 kg material is available. But how it is defined by 1 kg is nothing but a fixed value of Planck constant. That is important, right? This is previous one, speed of light. This one, constant. The third one is time. The unit is second. Yes, we know that the time is measured by either second or minute or hour. The base unit is second. But what is second? By taking the fixed value of cesium frequency. The cesium frequency is the reference. 1 second. 1 second is defined internationally by cesium frequency. Right? So these are all the 3 standard. How they are defining also available. Speed of light, Planck constant, cesium frequency. From this we are able to know what is 1 meter, what is 1 kilogram, what is 1 second. We are able to easily identify. Universally we are following the same unit for these quantities universally. We'll go for further some more another SI units. The fourth one is the electric current. The symbol is I. Ampere. The unit is ampere and the symbol is A. What is how it is defined internationally? Defined by taking the fixed value of elementary charge. Right? The fixed value of elementary charge will define the current. From that we are easily measure this is 1 ampere, 2 ampere, 3 ampere. But internationally what is meant by 1 ampere is fixed value of elementary charge. Then thermodynamics, temperature, theta. The unit is Kelvin, the symbol is K. We know that the temperature measured in Kelvin. Another one Celsius available, but Kelvin is the base. How we are measuring this Kelvin? Defined by taking fixed value of Boltzmann constant. Since this Boltzmann constant will define the temperature Kelvin, 1 Kelvin. That is K equal to 1.380649 into 10 to the power minus 23. So that will define the Kelvin. The next one is amount of substance. The unit is mole, symbol is MOL. What is that amount of substance? How it is defined? Fixed value of Avogadro constant. So this constant, Avogadro constant, will define the amount of substance. Then luminous intensity. The intensity means the lighting. What is the intensity? The unit is candela, symbol is CD. We know that this bulb is very bright, this bright is less. We are easily telling the luminous, but it is defined by fixed value of luminous efficiency. From luminous efficiency, we are defining the candela. So these 7 are the very basic SI units. All other SI units are derived from these base units, right? So what are the things are there available? Length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. For all, symbol and units are available, and how it is internationally defined also, the details are available. Now we'll see the SI derived units. 22 derived units we'll see. All these derived units are available from these base units. Okay, now we'll see the derived units one by one. So this is the name, symbol, quantity, and SI base units. From which base unit we are getting this? That is nothing but SI base unit. It's a combination of one or more base units. The first one is hertz. The symbol is Hz. What is the quantity? Frequency. The frequency is measured in the unit hertz. It is represented by Hz. What is that? S power minus 1. The base unit is S power minus 1. Next one, angle. It is measured by radian. The symbol is rad, R-A-D. That is 1. The base unit is 1. For angle, we have one more angle, solid angle. Steradian, SR. Steradian, SR, that is used for solid angle. Normal angle referred by radian. That also, the base unit is 1. The fourth one, Newton. That is for measuring the force. The unit is Newton. Symbol is N. For force, but the unit is Newton. The symbol is N. What are the base units here? Kilogram, meter, and S power minus 2. This is nothing but second. S power minus 2. So see this, there are 3 base units are available to define the term force. kg.m.s power minus 2. Then for measuring the pressure, you have Pascal, PA. For measuring the pressure, the unit is Pascal. The symbol is PA. What are the base unit? kg.m power minus 1, s power minus 2. Kilogram, meter, and second. kg.m power minus 1, s power minus 2. It's available for pressure. We'll go some more. Next, energy. Energy, the unit is joule, represented by J. For measuring the energy, the unit is joule, it is represented by J. What are the base unit? kg.m square dot s power minus 2. Right, kg m square s power minus 2. Then power. For power, the unit is watts, watt, represented by W. What are the base unit? kg dot m square s power minus 3. S power minus 3 for a power. Then electric charge is defined, is given, the unit is coulomb. The symbol is C, electric charge. What is that? S into A. S into A is a base unit. Then voltage is measured as, unit is volt. The symbol is V. What are the base units available? kg dot m square s power minus 3 into a power minus 1. These are all available for voltage. Then capacitance is measured with the unit farad. The symbol is F. kg inverse m power minus 2 s power 4 a square. That is a base unit for capacitance. Then we'll go to the resistance. Resistance, the unit is ohm. The symbol, this is the symbol. What is the base unit? kg dot m square s power minus 3 a power minus 2 for resistance. Similarly, conductance. The resistance and conductance are inverse. Is Siemens. Conductance is given Siemens. The symbol is S. What is the base unit? kg minus 1. kg power minus 1 m power minus 2 s cube a2. That is for conductance. Then magnetic flux is the unit is Weber. WB. The symbol is WB. The base units are kg dot m square s power minus 2 a power minus 1. Magnetic flux density is given as Tesla. The symbol is T. Magnetic flux density. Tesla. kg s power minus 2 a power minus 1. Right? The base units are kg s power minus 2 a1. Then inductance. Inductance is the unit is Henry. The symbol is H. kg m square s power minus 2 a power minus 2. The base units. Then temperature in Celsius. Already in base units available as Kelvin, but here is Kelvin. And one more unit is Celsius. Right? The base unit is K. 273.15 K. Right? So the Kelvin available in base unit, Celsius available in the derived unit. The next one is the lumens. What is the luminous flux? Luminous flux, the unit is lumen, is CD, candela. Then illuminance is lux. The symbol is 1x. CD dot m power minus 2. Then another 4 are available. Radioactive decay per unit time. Right? So the radioactive decays. These are all based on the radioactive radiations. Right? Becquerel is the unit. BQ is the symbol. S power minus 1. Observed dose of ionizing radiation. Gray, GY. M square S power minus 2. Equivalent dose of ionizing radiation. Sievert, SV, S power minus 1 mole. Then catalytic activities. That is Catal, KAT, S power minus 1 mole. So these are all the 22 derived units. These 22 derived units are obtained from the base unit. Now we'll see the multiples and submultiples. That is 10 to the power minus 4 to 10 to the power plus 24 available. We'll see the terms one by one. So we'll see what is the prefix for multiples and submultiples. How these units are represented with the prefix. First we'll see the start from 10 to the power minus 1. Then we'll go to this. These are all negative. We'll go to positive later. First we'll see the negative. 10 to the power minus 1 is prefix is deci. The character is D. D, deci means it is represented 10 to the power minus 1. 10 to the power minus 2 means centi, C. 10 to the power minus 3 means milli. The symbol is M. 10 to the power minus 6 is micro. The symbol is mu. 10 to the power minus 9 means nano, N. 10 to the power minus 12 means pico. The symbol is P. 10 to the power minus 15 is nothing but femto. The symbol is F. 10 to the power minus 18 means atto, A. 10 to the power minus 21 means jepto, Z. 10 to the power minus 24 means iacto, Y. So we can represent the units by using this prefix starting from 10 to the power minus 1 to 10 to the power minus 24 available. So we can represent using this. Similarly, the positives, the multiples also available. 10 to the power 1, 10 to the power 1 means deca, dA. 10 to the power minus 2, 10 to the power 2 means hecto, h. 10 to the power 3 means kilo, k. 10 to the power 6 means mega, m. So these are all multiples that are the previously what we did is submultiples. 10 to the power minus 10 to the power 9 is a giga, g. 10 to the power 12 is tera, t. 10 to the power 15 is peta, p. 10 to the power 18 is exa, e. 10 to the power 21 is zeta, z. 10 to the power 24 is iota, y. So here is the multiples available from 10 to the power 1 to 10 to the power 24. So in this video we discuss what is SI unit, what is SI base unit, what is derived units, and we discussed the 7 base units, 22 derived units, and also multiples and submultiples. Thank you. Welcome viewers. In this video we'll see the active and passive components. First we'll see the active component. An active component is an electronic component supplies energy to the circuit. So due to this it is called as the active component. This energy is supplied to the circuit. That component is able to supply the energy to the circuit. So what are the examples are available? Voltage source, current source, generator, all type of transistor, diode. These are all the example for the active components. They are able to supply the energy in the circuit. Now we'll see this one by one. First we'll see the voltage source. The voltage source is an example of active component. When current leaves from positive terminal of the voltage source, energy is being supplied to the circuit. So when the voltage source is connected in the circuit, the voltage source able to supply the energy into the circuit. So that's why it is called a active component. Similarly, the battery also considered as active component because it is continuously deliver the energy to the circuit during the discharging. Right? So the voltage source as well as battery are the active component because they are supplying the energy to the circuit. Similarly, the current source. Current source is current supplied by the supplied to the circuit by the ideal current source is independent of the circuit voltage. So the current source is controlling the flow of charge in the circuit, so it is classified as the active element. So the current source able to supply the current to the circuit continuously, independent of circuit voltage. It is always delivering the current to the circuit. So that's why it is called as a active element. Then the transistor. The transistors are able to amplify the power of the signal. So that it is also called as a active component. The transistor is one of the main component in the amplifiers. So transistors are able to amplify the power, so that it is called as a active element. Now we'll see the passive elements. I will see the passive component. Passive component is an electronic component which can only receive energy. So active component means deliver the energy. Here receive energy. It can be either dissipated or absorbed or stored in the electric field or magnetic field. So the passive component means it will receive the energy. That energy can be either dissipated or absorbed or stored in the form of either electric field or magnetic field. In previous active component that deliver the energy. Here the energy is receive the energy. Passive element do not need any form of electrical power to operate. There is no specific power is needed to operate this element. If you connect in the circuit, it will do the work. No need to go for any power to operate. Passive device do not provide gain or amplification. It will not provide any amplification. Either it will absorb the energy or dissipate the energy or store the energy. it cannot amplify, oscillate or generate an electrical signal, right? It will not do any amplification. We'll see the examples one by one. First we'll see the resistor. Resistor cannot deliver any energy to the circuit, but it will receive the energy and dissipate as a heat as long as the current is flowing. So no power is required to operate the resistor. Once the resistor is connected, it will absorb the energy and dissipate in the form of heat, right? So that is the done by the resistor. Similarly, inductor. This inductor can store the energy in the form of magnetic field and can deliver that energy to the circuit. During discharging, it will deliver. So inductor can store the energy in the form of magnetic field. Similarly, capacitor. The capacitor can store the energy in the form of electric field. During the charging time, it will store the energy. So the resistor will receive the energy and dissipate as a heat. Inductor will store the energy in the form of magnetic field. Capacitor will store the energy in the form of electric field. Then the transformer. So the transformer, we have step up transformer or step down transformer. It will increase the voltage or decrease the voltage. Secondary voltage may be greater than the primary voltage, or secondary voltage may be less than the primary voltage. Here the voltage is increased, but power and energy remain the same. There is no change in the power. When the voltage increases, automatically current will decrease, so the total power remain constant both in primary as well as secondary. So there is no amplification, only the voltage level changes. Accordingly, the current level also changed. While increasing the voltage in the secondary side, the current will decreases. While decreasing the voltage in secondary side, the current will increases, so that power remain constant in primary as well as secondary, right? So this resistor, inductor, capacitor, transformer are passive elements. No specific energy is needed to operate, just it will absorb or it will receive the energy. There is no amplification done by this component, that's why it is called a passive components. Now we'll compare this active and passive components one by one. Now we'll compare this active and passive component. So the active component means active device transform and inject power or energy into the circuit. It will deliver the energy or power to the circuit. But passive component utilize the power or energy into the circuit. Either it will absorb or dissipate as a heat, or store in the magnetic field, or store as a electric field. It will receive the energy, but here it is the energy is injected into the circuit. Then next point, all element produces energy in the form of voltage or current. Active elements are produce the energy in the form of voltage or current. Passive elements store the energy in the form of voltage or current, right? It will produce the energy in the form of voltage and current. Here passive element store the energy in the form of voltage or current. They have function and provide a power gain. For example, transistor is a power amplifier. So the amplification is possible, power gain is possible, but in passive component they do not have any provide power gain. Power gain is not possible in the passive component, just it will absorb the energy. It can control the flow of current. For example, amplifier, automatically it will control the flow of current, but it cannot control the flow of current. Right? Just it will absorb or store the energy. Active components require external and conditional source to operate in the circuit. Right? This amplifier other than voltage source, current source mean we need to give the supply to the voltage source, then only it will work. So the external and conditional source is required. For example, power amplifier mean we need to give the power, then only it will be amplified. So external and conditional source is required to operate this active components. But in passive components do not require any external source to operate. Just it will While connecting, it will absorb the energy what is available in the circuit, and either it is stored or it will absorb in the form of heat. Right? So the external source is not required for passive components. Now we'll see some examples. So already we discussed the diode, transistor, solar PV cell, PV panel. These are all the example for active components. That is, it is able to deliver the energy to the circuit. It is able to go for a power gain. For this, the external source is required. But while going to passive components, it will not deliver. It will receive the energy. But no specific power is needed to operate. There is no power gain also. What are the example? Antennas, capacitors, detector, inductor or coil, network, sensor, transducer, cable, crystals, PCB, switches, terminals, connectors. So these are all passive components. Just while connecting in the circuit, it will receive the energy from the circuit. It will not go for any amplification. It will receive the energy and it will do the work. Right? So in this video, we discuss about what is active component, what is passive component, what are the examples available, what are the comparison available, we discuss. Thank you. Welcome viewers. In this video, we'll see the unilateral and bilateral element. First, we'll see the unilateral element. So the unilateral circuit elements are those elements that allow the flow of current in only one direction. It will allow the current in only one direction. So when the polarity of the power supply changed or reversed, either it will oppose the flow of current or shows the different property. So it can able to, the current will flow in only one direction. Suppose if you reverse the current or reverse the polarity, it will work with the different characteristics. So that it is called a unilateral. Unilateral means only one direction. If the direction changes, its property will change. So the VA characteristics of unilateral element changed when the polarity of the applied voltage reversed. Right? It will give the different VA characteristics. It will work only one direction for a current flow with the only one direction. If any change in the current direction or polarity, the property will change. Right? So the example for this unilateral element, diode ACR. So the diode ACR, so we know that forward bias and reverse bias. If anode is positive with respect to cathode, this is forward bias. If anode is negative with respect to cathode, it will reverse bias. So during forward bias, conduction is there, but during reverse bias, there is no conduction. So while changing the polarity, the property of the diode also changes. Similarly, ACR also. The ACR also very similar thing. Only thing you have gate terminal. So the anode is positive with respect to cathode. While giving the gate signal, it will start conduct. Suppose if anode is negative with respect to cathode, it is reverse bias. Even if you give the gate signal, it will not conduct. So during positive application of voltage, it will conduct. But if you apply the negative voltage to anode, it will not conduct. So that it is called a unilateral element. So the circuit using diode and AC are called a unilateral circuit. Right? We will see the circuit diagram. So this is nothing but a bridge rectifier. So 4 diodes are available, D1, D2, D3, D4. So this is entire circuit is called a unilateral circuit. So this is the unilateral element. This diode is the unilateral element. It will conduct only in one direction, positive. During negative mean it will not conduct. Right? The AC voltage is given, we are getting the DC output. So during positive half cycle, D1 and D2 will conduct. D3 and D4 will not conduct because reverse bias. During negative half cycle, D3 and D4 will conduct, but D1 and D2 will not conduct. So it will work in only one direction. In order to get both positive and negative direction, negative cycle, we are having 4 diodes are connected. So it will work in a one direction. Now we'll see the bilateral element. Now we'll see the bilateral element. Bilateral elements allow the current to flow in both direction through them. It can be able to, the current can flow in both positive direction as well as negative direction. The VI characteristics of bilateral element do not change so much with the reversal of the applied voltage. So during positive or negative, either the current direction is positive or negative, the characteristics will not change much more. It can be able to function for both positive current as well as negative current. They are mainly three passive elements, means they are not require any external voltage to work, and all of them are bilateral in nature. Basically there are three passive elements available, that is nothing but resistor, inductor and capacitor. These three are also called as a passive element. There is no external source is required. The active and passive element, the separate video available, the link is available in the description box. The viewers can see that what is meant by active and passive components. Available separate video, the link is available in the description box. So this resistor, inductor, capacitor is called a passive element that do not require any external force, external source. So during the change of current, polarity of voltage or current will not much more affect, right? It will act as it is. So the example is resistor, inductor, capacitor. So this bilateral circuit is available. It's a connected resistor. So either the current is positive or negative, it will act as a resistor. It will absorb the power. It will not bother about whether the current is positive or negative. Now we'll go for a comparison between unilateral and bilateral element. We'll go for a comparison. So we'll compare this unilateral element and bilateral elements. So in unilateral element, it allows the flow of current in one direction only one direction. But it allows the flow of current in both the directions, right? Both the direction is possible. The VI characteristics change with the reversal of applied voltage, right? We already discussed forward bias and reverse bias of the diode. If we apply positive voltage, it is forward bias diode. If we apply negative voltage, it becomes reverse bias. So the polarity will change, the characteristics also will change. But here the VI characteristics do not change with the reversal of the applied voltage. Here will not change. For example, here we have resistor, capacitor and inductor. And one more point is available. The resistance and impedance property vary so much with the varying the following current, while varying the flowing current, right? So in this case the property will change, but the resistance and impedance property do not vary so much with the varying the flowing of current, right? Why? Because diode SCR is very important. Positive voltage is applied means forward bias, negative voltage applied means reverse bias to the anode. But here, so it will vary the property, but here not like that. Either positive or negative voltage, this resistor will absorb the energy and dissipate in the form of heat. Inductor will store the energy in magnetic field. Capacitor will store the energy in electric field, right? Much more change, right? So in this video we discuss what is unilateral element, what is unilateral circuit, what is bilateral element and bilateral circuit, and comparison with example also we discussed. Thank you.